So this is a perfect square. There's a way I can tell, just look, you can tell it's not a parabola, I hope, because both the x squared, x and the y have got a squared term. I can look at it and know it's an ellipse, and you'll know that by next week. Okay, this is a perfect square because there's no other term with x's in it. This, the 3y squared and the 36y, we're going to have to turn that into a perfect square so we can get it in graphing form. And to do that, we'll move this 60 to the other side, so we'll have minus 60. Factor the 3 out from the y squared, so we'll have 3 times y squared plus 12y, and you'll have to complete the square on that, and don't forget you'll be adding 3 times whatever number you use to complete the square on the other side. Now I put an error there. Can you see what my error is? No, I fixed it. I don't have an error, I fixed it in my last class. Okay, so I hope you all got that. Okay, so this would be an ellipse, and if you graphed it, let's graph this quickly. Your HK point 0 across, 6 down, 1, 2, 3, 4, 5, 6. There's the center. Remember, this is underneath x. This is just an x distance squared. So if we take the square root of 12, which to graph it is disgusting. Well, it's easy to graph. That's about a number that's a bit bigger than 3. And that means from the center, we're going to be going that square root of 12 about 3 and a bit either way. So 1, 2, 3 and a bit. 1, 2, 3 and a bit. Oh, I haven't drawn this scale at all. Never mind. It's not going to look like an ellipse. It's going to look like one way. I have to draw that better to scale. My spaces are smaller. 1, 2, 3 and a bit. 1, 2, 3 and a bit. There you go. That's all to scale. And to go left, we're going to have to go left and right. I mean up and down underneath the y by the square root of 16. So we're going to be going up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. There's our ellipse. It's got foci which must be drawn, and you've also been asked for the eccentricity. So to draw the foci, they're going to be, it's vertical, they're going to be somewhere on this major axis that is of length 8. Yeah, 4 up, 4 down, and those together, that's 8. And to find out where the foci are, we're going to have to do a squared equals 16, the big one, b squared equals the other one. Subtract them, and that will give us c squared is 4. So c itself is going to be 2. So to get to our foci, we're going to go up 2 and down 2. And those are supposed to be marked on your graph. But we also need this, and we need A is this one, the large one is 4, to get the eccentricity. Eccentricity is C over A, so it's 2 over 4, which could be written as a half. And another form that number could be written in is a decimal. In pre-cal, we often don't use decimals, but did you notice it on the quiz yesterday where we actually put a decimal in for something that you should know the decimal of? Okay, let's look at this one. Okay, it's definitely not a parabola. Do you notice something here? Oopsie. Those have got the same coefficient. That's going to make this very interesting. When we complete the square on this one, I'm going to get my x terms. So I've got 4 times x squared, factor 4 out from that, to be minus 4x plus, so I'm going to let myself through. Move all this down here. Then my y terms, factor that 4 out of these two. If you could have divided all those numbers by 4, but I'm just showing what it would look like if you didn't. Then we'd have to complete the square on that one. And there was nothing left. So that side, there's nothing to move across. That side would be 0, but don't forget you've got to add in the squares you complete. When you complete the squares, so you have 4 times something and another 4 times something. So let's turn these into perfect squares. This is 4 times x minus 2 squared. And if you FOIL this out, you wouldn't just end up with x squared minus 4x, you'd end up with x squared minus 4x plus 4. Yeah? You halve that number, bring it down, square it, bring it back. That's the pattern that you follow to do it easily. And on this one, we get 4 times y plus half of that. Square it, put it back. So on the other side, we have got, this is 16, that's 4, we've got 20. Now to make this into ellipse, I divide by 1, I divide by 20 to make it 1. 4 goes into 25 times, 4 goes into 25 times. So there's our equation, and it now looks like an ellipse, but we have a bit of an issue with it. Is it horizontal or vertical? Well, it's neither. Let's graph what we've been given. Okay, so we would have a center at 2, -1, and then we would be going the square root to go left and right. We're going to go the square root of 5, which is a number a little bit bigger than 2. So a little bit bigger than 2 to the right, a little bit bigger than 2 to the left, and we're going the same distance up and down. So this actually turns out to be a circle. And the radius of the circle is the square root of 5. On an ellipse, we normally go left and right A, up and down, depending if it's horizontal or vertical, left and right by the mount from the center, up and down from the mount from the center. These are the same any direction you go. So this is what makes the circle. Now make yourself write some notes now. Okay, write all these notes. A circle is a special ellipse. It is an ellipse, but it's special. It's like a square is a special, what's the word I'm looking for? A square is a special rectangle. A circle is a special ellipse. Okay. Because it's special, can you see how we could actually change the format of this equation? These denominators are both the same. We could get rid of them by multiplying this side by 5 and multiplying this side by 5. Then that would cancel those, and we would be left with x minus 2 squared plus y plus 1 squared equals 5. Not 5 squared, just equals 5. So that gives you the standard form also known as the graphing form of the equation of the circle. X minus h squared plus y minus k squared equals r squared. That is the standard form for a circle, and it only works because in an ellipse form, you would have divided by r squared, divided by r squared, divided by r squared, and when you cancel here and here, here and here, you end up with the same values, yeah? So we don't write it like that. Why make it look so complicated? What you must know when you've been given a circle is the center is at HK, and this number here is not the radius. It is the radius squared. So if you want to find the radius, you have to take the square root of that number you're given. okay, to get the radius. Okay, so let's do some more practice on these. When I was over the board, could you hear me or was I way too quiet? Right, let's move on. Oh, I forgot to work out the eccentricity of that circle. Okay, right, so clear out all this jump. Okay, so what is the eccentricity of a circle? Let's look at this. And where are the foci? To find the foci and to find C, to find the eccentricity, we need to do this. A squared equals B squared equals, the difference would give us C squared. Well, A and B on that example we just did up there, A squared was 5 and B squared was 5. So C squared is 0. The foci are no distance at all away from the center. The foci of the circle are at the center. And the eccentricity, which is C over A, would be 0 over the square root of 5. Your eccentricity would be 0. Why? Because remember, eccentricity is a measure of how far away from being a circle you are. So when you've got a circle, you're 0 distance from being a circle. The eccentricity of every single circle, the eccentricity, stop that wrong, always will equal 0 for every single circle, and the foci are at the center. And when you have ellipses, they have special properties. If you have your two focal points, any signal or energy that's radiated out from this focus will reflect off the sides and arrive at the other focus. It's going to travel the same distance, it's going to arrive there at the same time. So you can create an echo chamber. You can make a sound from here, and every single bit of sound you produce gets heard here. And you've probably noticed that when you walk through the rotunda at school, as you walk over the central spot, because the ceiling is a three-dimensional sphere, every single bit of noise you make at that point reflects back onto you. It's one of the applications of ellipses and spheres. Okay, so let's do. We've got those. We're going to skip that extra work. We're just going to do 2 examples in class today, okay, of this form. We're going to do 2 examples of this form. And what we're going to do is we're going to ask you to write the equation and graph these circles. There's going to be 2. This is example 1. If we had a circle that passes through the point 4, -2. So the circle goes through that. That is a point on the circle. And we've been told that the center of the circle is at 1, -2. So that's your HK point. That's going to be easy to fill in. The basic shape of the equation is going to look like this: x minus h squared plus y minus k squared. And this will be our radius squared that goes here. So all we do is we get that HK point, put it straight in here. So we'll have x minus 1 squared plus y minus -2 squared. And all we have to do is to find the radius. And we know that the circle passes through that point. What do you call the distance from the center of the circle to a point at the edge? You call it the radius. So we find the radius by just looking at the distance between these 2 points, going from the center to the edge. And it's a distance, so you're not going to call it negative. Whichever way you go, you're going to call it positive. If you look, the y's haven't changed. The only change you've got is in the x's. So to go from the center to this edge point, the change is 3. So we know our radius equals 3. Here to here, there's no change. Going from here to here, the distance is 3. And that is from the center to the edge. So that's our radius. So our radius squared is what we need to put in here. So we're going to put in 3 squared, and here is Okay? And when you're graphing it, it's very simple. From the center, just go left and right by the radius, up and down by the radius, and do your best job to try and sketch in that circle. So from the center, just count to 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? And then if you needed to, you could calculate these points on the circle. Right, let's try another example. Let's make this one slightly harder. So I want you to try this one on your own for a while. Oh dear. Let's clear that stuff off here. Okay. I'm going to pause the video now. So you're going to find this easier by sketching it. This is going to give you the very easy start to your equation. And you've got to think about how you would work out that radius. So here's our HK point. It's definitely going to be x minus 2 squared plus y minus -3 squared. And all we have to do is find that number. And what we're going to put in there is going to be the radius squared. So we have to find the radius, and then we will square it. Okay? And the radius is going to be the distance from this point to this point, from the center to the edge. And this time it's going to be a little bit harder because they haven't, both the x and the y changed. Okay? You could, if you were slightly insane, say the radius is the distance between those 2 points and use the distance formula, but you really don't need to do that. You can do this if you want to, I'm saying don't, but that's mindless. That's doing it without thinking, and it's memorizing the formula without really understanding what that formula means. This formula, what this formula is actually doing, is getting 2 points, it's creating a triangle between them and using the Pythagorean theorem. When you sketch this, your radius is going to be a slopey line, yeah? All you need to do is work out that x distance, that's your change in x, that y distance, that's your change in y, and use the Pythagorean theorem, and think carefully about what you write here, okay? Think carefully about what you write there. Any questions at this point? One thing I forgot to point out is how can you tell, just looking at an equation, that it's a circle? Well, we can tell at this point, looking at this one, that it's not a parabola because there's both an x squared and a y squared term. But can you tell, just looking at it, that this one is an ellipse and this one is a circle? You see the difference? You just have to look at the squared terms. On this one, there are different coefficients. After you finish completing the square, subtracting 60 to this side and adding 4 times, was it 36? No, it was 3 times 36 from here and 4 times nothing from this one. You end up with a number that you have to divide through. And the 4 would simplify with that number differently to how the 3 simplifies with it. But on this example, when you complete the square, whatever number you end up with on this side, and then you divide it across, the 4 will simplify it with it exactly the same way as this 4 simplifies with it. Because these coefficients are the same, there's one more thing, you'll find out about that next week, because you're adding both your x squared and your y squared terms, and they've both got a coefficient that's the same. You can tell immediately just looking at the equation that this is going to be a circle. If we look at some more examples, this is a circle. You've got 1x squared plus 1y squared. These ones we did in class, we didn't have the equation. This is going to be a circle because you've got 3x squared plus 3y squared. These coefficients are the same. And on your homework, there's this horrible, horrible one You can tell it's going to be a circle. When you complete the square on this one, it's horrible. It involves lots of fractions. You've got 8x squared plus 8y squared. So it's going to give you a circle. Why this one is absolutely horrible. Let me show you this one. Gosh, it's really vile. It's absolutely vile. If I complete this square, I'm going to factor out 8. So I've got x squared plus 6 divided by 8. Ooh, that's 3 over 2. 3 over 4 x. And then I'm going to add something to complete the square on that. And on the y terms, I've got another nightmare brewing here. I've got 8 times y squared minus that divided by 8 would be simplifies to both numbers are divisible by 4. No, 3 over 2. Then it equals the hundreds already over there. But we're going to have to add 8 times whatever goes in that box. I'm drawing it big because I know some horribles in there. And 8 times what goes in that box. You know what I could have done to make this question a little easier from the beginning is I could have divided all those numbers by 2. Oh, well, I didn't. So what have we got here? We've got 8 times x squared plus half of this. I've got to multiply the denominator by 2 to get half of it. Oh, completed the square. I don't put square there. X plus 3 over 8. Square that and put it back, and I get 9/64. Oh, this is horrible. This is just horrible. Then we get 8 times this, y. I'm completing the square. So that'd be 3/4. Dividing that in half, you're multiplying that denominator by 2. Square that, put it back, you get 9 over 16, and I'm going to add 8 of those. And then we have to sort all that out. So on this side, we have to add all this up. Right. 8 goes into 64 8 times. 8 goes into 16 twice. So I'm going to have to add these together over a common denominator of 8. This would be 800. Oh, I'm really writing 8,000. Got 800 over 8 plus 9 over 8 plus this would have to be multiplied by 4 plus 36 divided by 8. So I've got 800 plus 45. I've got 845 over 8. Yuck. Then what I could do to turn it into a circle is I can actually divide these 8s away. So my answer is x plus 3/8 squared plus y minus 3/4 squared equals 845 over 64. And if I've got that right, I'll be very surprised because I just worked that out off the top of my head and I was rushing and I haven't done it carefully. So I'm going to have to go check that. I have no idea if I've got it right. Yikes. That's why that was so horrible. Please don't worry, we're not going to give you one like that on the test or anything.